Hello, welcome to this video where we look at now combining transformations. Pretty straightforward. Instead of just applying one translation, we're going to combine multiple forms of them together as we form a new image of a function. So to cap off what we've covered so far, we've looked at translations. Okay, and this is sort of looking at it from a dash method point of view, okay. Which is the more technically, I guess, correct method or mathematically robust method. So here we have translations where we are horizontally or vertically moving the graph. Dilation, where we are either horizontally or vertically compressing. Okay, so we're stretching it out away from the axes. Key thing to hear, this is stretching them from or compressing them about the axes and not a turning point. We're so used to working with quadratics and everything happening around the turning point. That isn't the case. We're stretching these from the axes. And then finally reflection. So reflecting about the x-axis where we flip it vertically, or reflecting about the y-axis where we flip it horizontally like that. So in this exercise, we'll now combine two or three of these transformations. It was in the very last couple slides of the previous exercise, but we'll have a now proper look at it. So we'll do this first via dash method, then we'll do using inspection or intuition, using the inspection rules. Yeah, and we'll go from there and we'll build and build and build. So let's have a look at this example. A reflection in the x-axis followed by a dilation of a factor of 3 from the y-axis, followed by a translation of 2 units in the negative direction of the x-axis and 4 units in the positive direction of the y-axis. So we've got a fair bit going on there. Okay, so first steps first, we've shown we have the reflection. Okay, so the first step, we have our reflection. Then we have our second step, which is our dilation. Okay, followed by a translation, a double translation. So we may as well call this 3 and this will say about here. They're together, okay, because we can do translations together. The other ones, they have to be done separately as the order matters. Okay, so we have step 1 where we apply the reflection about the x-axis. Okay, so if we think about reflecting about the x-axis, we're actually flipping it vertical. Okay, so we're making the y values negative of what they are, or we're changing the sign of the values. Okay, so that's what's applied right there. We've made y into negative y. Every y coordinate, we have changed its sign effectively. Now, second step, followed by a dilation of factor of 3 from the y-axis. Okay, so if we are dilating from the y-axis, that means we are stretching away from the y-axis. Okay, we're dilating by a factor of 3. That means we're stretching away. If it's less than 1, then that means we're compressing. So we're stretching away from the y-axis. So that means we're actually changing the x-coordinates. We're multiplying, okay? We're multiplying every x by 3. Okay? So we have now 3x negative y. And now, translations. So we're translation of 2 units in the negative direction of the x-axis. Okay, so we have our 3x and we are now going to move it 2 units to the left. So we take away 2 from it, from the x-coordinate. Every x-coordinate then has 2 taken away from it. That shifts it left 2 spots. And 4 units in the positive direction of the y-axis. So every y-coordinate that we currently have, which is this negative y, is going to have 4 added to it. It's going to be shifted up 4 units. So therefore, our final rule is 3x minus 2, negative y plus 4. Okay? And we could say that is equal to x dash comma y dash. That's going to be our new coordinates. Take our old coordinates, do these operations to them. That will give us our new coordinates of our new image. Okay, so once we've found a rule for a series of transformation, is applied just the same way that we've done in previous exercises. Okay, so here is another so we've now been given the equation. We've got y equals square root of x under a reflection in the y-axis, followed by a translation of 3 units in the positive direction of the y-axis. So here's the breakdown of doing that. So again, just quickly to point out, so reflection in the y-axis, that's transformation number 1 in the order we're given. And then we are given followed by translation 3 units, positive y-axis. Okay, so that's what it's applied here. That was step 2, sorry. So we have transformation number 1 is all x values have their signs switched, which is a reflection about the y-axis. And then we have transformation 2, which leads us to negative x, and then our y values have 3 added to them. So that's pretty straightforward. Applying those, we're stacking them on top. The way we can think of doing multiple transformations is we stack them on top of each other. We do one transformation, then to that we apply another transformation, and then to that we apply a third or fourth, or however many we need to do. Okay, so we have x comma y has been transformed into negative x y plus 3, so we can say that is equal to our x dash y dash. That's our new coordinates. So we can break that into our x component and our y component right there. Okay, and we rearrange them to get them in terms of x and y, not x dash and y dash. And then once that's done, we substitute them into our original equation. Okay, so our original equation, just so you can sort of see, we had y equals root x. We sub in the equations at the start. So we now end up with y dash minus 3 subbed in for y equals the square root of negative x dash. Okay. And then the last thing is you rearrange it to actually look like a normal equation. So we aren't used to dealing with operations being done on the y. So we get y dash equals root negative x plus 3. Okay. So that gives us the transform function, or what we've also been referring to as the new image of the function. So if you went to Desmos, typed in the original function, and then typed in this new image one, it would look just like the original, reflected in the y-axis, and then translate 3 units in the positive direction of the y-axis. Okay, so let's have a look at that same problem using inspection. Okay, so the thing with inspection is you've just got to remember the inspection rules or the inspection procedures. So we've got them stated here. As we said, our first step, reflection in the y-axis, is 1, and then our second step here is 2. Okay, so to do step 1, reflection in the y-axis, replace x with negative x. That's just the rule for inspection. Okay, so we started with y equals root x, so we take that root x and replace it with negative root x. Step 2, okay, translation of 3 units in the y-axis. That means we just add 3 to the equation at the end. Okay, so when we're doing at y-axis, we just add at the end. Okay. So we've got y equals negative root x, and then we just add 3 on the end, so we get our answer. Okay, again, inspection much quicker, but the dash method is more rigorous. Okay, so I will attempt to do both of these following examples using both methods. It might get a little cramped here, but I'm going to do it with both methods. So find the equation of the image of y equals 1 on x. Okay, so we're finding the new image. This is our old. We need to find a new image where this has been reflected in the x-axis. So I'm going to underline these and name them It helps break down the problem, what are the transformations, followed by a dilation of a factor 2 from the x-axis. So that's our second transformation. Third transformation followed by translation of 1 unit in the positive direction of x-axis. So I'll call that 3, and then I'll go back to red. We have 3 units in the negative y-axis. So I'll call that number 4. I'll do them separately so we can see what they're like. Okay, so we're starting with using the dash method. We're starting with coordinates x, y, and we apply a transformation to it. We apply step 1, which results in a reflection in the x-axis. So if we're reflecting about the x, our horizontal axis, we reflect. That means we're flipping it. That means all our y values, like in the last video, that means all our y values have their sign change, which we can achieve by just putting a negative sign out the front. Now we'll do transformation 2. So we're dilating as a factor of factor 2 from the x-axis. Okay, so we're dilating as a factor 2 from the x-axis. So that means we're stretching away from the x. That means it's actually changing our y values by a factor of 2. So we get x 2 by negative y, because we're applying it on top of, so whatever's been done, and this is the big difference between the dash method and the inspection method. Inspection method, you're doing it directly to the variable. You're doing it always as close as you can to the variable, while in the dash method, you apply it on top whatever's been done before. Okay, so I could say that's the same as, so I'll just put an equal sign here for now, that's the same as x, comma, negative 2y. Yeah. Now we will apply on top of that transformation 3. So we have x, comma, minus 2y, where we are going to translate 1 unit in the positive direction of the x. So every x value has 1 added to it. So we have x plus 1, comma, and we still have our negative 2y, comma. Okay. And now we apply our last transformation to that, which is transformation number 4, okay, which is 3 units in the negative direction of the y-axis. So x plus 1 stays the same. We have our negative 2y, and then on top of that, we are now going to subtract 3. Cool. So we've now built that where we can now say that's our final transformation, x plus 1 negative 2y minus 3 is equal to x dash comma y dash. Therefore x dash plus x plus 1 equals x dash, and we have negative 2y minus 3 equals y dash. So rearrange it to get x and y by themselves. So we get x equals x dash minus 1, and we have y equals y dash minus 3, all on negative 2. And to make that a little easier, I'll move the negative sign into the numerator. So we get it's equal to negative y dash plus 3 on 2. So I've just moved the negative into the numerator. So we can now substitute these two into our original equation. So sub into, what do we have? Y equals 1 on x. So it follows on, we have negative y dash plus 3 on, oh, I've just noticed in the comments a whole bunch of last year's year 12s are heckling. Very good, gentlemen. Very good. Good to see you here. I guess you got nothing better to do if you've all dropped out of uni, maybe. I don't know. Just making an assumption. 2 is equal to It actually be good to know what you are all up to. Is 1 on x dash minus 1. So we now need to make this look like a standard function where we have it just y equals. So that will be negative y dash plus 3 is equal to 2 on x dash minus 1. So we get negative y dash equals 2 on x dash minus 1 minus 3. And then finally, we have y dash is equal to negative 2 on x minus 1 plus 3, bringing the negative all through the opposite side. Sound clap. Brat career. Very good. Very good. Okay. So a lot of working out. A lot of working out, but if you follow the process for the dash method, no mistakes. So if we use the inspection method, we're starting with y equals 1 on x. Okay, to do step 1, we are reflection in the x-axis. So if we're reflecting in the x-axis, we replace y with negative y. Okay, so we get negative y equals 1 on x. To do number 2, so we have a dilation of factor 2 from the x-axis. So if we're dilating from the x-axis, we replace y with y on 2. So we get negative y on 2, and this is the difference with inspection method, is equal to 1 on x. So we're replacing the variable directly, as close as you can get. When it says replace, you do directly, and then anything around it's left outside of it. Okay, so to 3, 1 unit in the positive direction of the x, so we replace x with x. And this is another weird thing with the inspection method. For the horizontal translation, we know it's switch the sign, so we get negative y x. Where did I make I misread way back. When did I not? To 1 unit. No, that was all right. Oh yes, I've misread for this. We're translating horizontally by 1, so we get negative y on 2 is equal to 1 on x minus 1, and then stage 4 is, since we're doing a vertical translation, we add 3 to the end. So we get negative y on 2 equals 1 on x minus 1 plus 3. And then if we rearrange that, we get y equals negative 2 on x minus 1 2 plus 3. So we've ended up with the same thing. Okay. So that's how we apply them together. Divide by factors. So, having you guys still. Mike has a question. Fire away, Mike. If you have a question, fire away. Looks a lot like McIntyre's notes. Yeah, they're modified McIntyre notes. He's got a good system. No need changing something that works well. Find equation of the image of the graph y equals square root x translated 3 units in the negative direction of the x-axis, then reflected in the y-axis, then dilate by a factor of 3 from the x-axis. Okay. So, find the equation of the image graph y equals square root x. So we're starting with our coordinates x, y, applying our first transformation, translate by 3 units the negative direction of x-axis, so that's x minus 3, comma y. Second transformation, reflected in the y-axis, so that means we're making all the x, changing the sign of the x values. So we get negative x minus 3, so we're applying the negative to the whole value, comma y, and then our last transformation reflected in the y-axis. So, oh no, sorry. We did reflect in the y-axis, then dilate by a factor of 3 from the y-axis. So we're going to end up with negative 3x. Let's go to the next line. We end up with negative 3x minus 3, comma y, which is equal to x dash y dash. Therefore, x dash is equal to negative 3, x minus 3, y is equal to y dash. So rearrange, we get negative x dash on 3 is equal to x minus 3, so we get negative x dash on 3 plus 3 is equal to x, and y dash is equal to y. And we sub into like normal, okay? So the only part new is this, is stacking the transformations. That's the only new bit. Okay, so sub into y equals root x. So we get y dash is equal to the square root of negative x on 3 plus 3. The nice thing about this is we don't need to change it around. It's already in the form of y equals, so that's really handy. So let's do it using inspection. Okay, so we start with y equals root x, translate 3 units in the negative direction of the x-axis. Okay, so that means we replace x with x plus 3, because it's inspection we have to swap the sign, so we get y equals root x plus 3. Okay, second step, second transformation reflected in the y-axis. So if we reflect in the y-axis, we replace x with negative x, so we get y equals square root negative x plus 3. And then our third transformation, where we dilate by a factor of 3 from the y-axis, that means we replace x with x on 3. So we get y equals negative x on 3 plus 3, all in the square root. So we get the square root of negative x on 3 plus 3. Raj, 45 study scoring methods. Yeah, one of you had to do well. Yeah. So we have that. So we get the same solution. Both ways we get the same solution. I will leave example 4 for you to have a go. If you have any questions, jump on Edmodo or send me a message through Compass. That is it. Good to see the old Year 12s drop by. I had a bunch of those guys. Year 12 last year for physics and methods or for physics 2 years ago. So I hope they're doing I actually hope they are doing okay, especially considering everything that's going on with the coronavirus. I hope you're all staying safe, guys. Hopefully you're doing okay at uni, if you've gone to uni or whatever you've decided to do. But see ya.